So the first translation we're going to talk about today is the when we have movement on the y-axis. So where we can see our function will have a plus or minus of certain value. Now sometimes it will be referred to as a translation from the x-axis. So when we see from the x-axis, it's actually it's the y value that's being affected. Because if we have a look at our example just here, so if we sketch the original y equals 1 over x, we would see this where it's asymptoting on the y equals 0 and x equals 0. But if we translate it and we see this 1 plus 1, we actually see movement of it going up and down parallel to the y-axis or in the y direction, because see in the blue arrow here we see that it's moved up the asymptote, so it's translated is what we say. But if you had a look at a point, you can see that it's just the y value that is affected by that. So sometimes when we're talking about translations, we're going to talk about like a point, or you can refer to it. So if you think of a point or a coordinate of the original graph as x and y, when we have the new formula, it's called the image. So they might say find the image formula. And when we talk about the image point, we often refer to the x with the little dash and a y with a dash, so that means that. So when we actually have translations of where the y value is affected, so we're moving it up and down, you see that the y value is affected. So if we looked at the new x, it will actually be the same as the old x, but the new y will be y plus whatever translation has happened. So if it was plus up, moved up or down, and we will look at that a bit later. So if we have a look at this second graph down here, if the function equaled x squared, it said sketch the graph of the function. Now this means we might say it's moved 2 units in the positive direction of y. Okay, so if they said that and you were thinking of the points, well, we know the x point remained the same, but the y point was the original plus 2. So if our original function was, say, y equals x squared, we want to put the new formulas into that. But if you have a look, if you transpose this, the new dash, it would be minus 2 equals y. So if you put these new things in where you see y and where we see x into the formula, so we'd have y minus 2 equals x dash squared, we can see that you essentially get x squared, and if we move that 2 over, it'd be plus 2. So you can see how using the image point, we can create the formula for it. Okay. Just over here, I have shown for this one, I've just shown you how to get the x-intercept. Like if you were asked to sketch a new function, we've done lots of that. So x-intercept, y equals 0, and you pop in a range. Okay, the next type of transformation we're going to look at is when the graph is translated left or right. So we see the graph moving left or right. And we know if we see a positive value added to the x, that moves the graph to the left. So if we were just thinking about that, if you move the graph to the left, you're actually moving the graph in the negative, you're moving the graph c units in the negative direction of x. So of the x-axis, sorry. So if you think about the new point, we are affecting the x. So you're actually going, so if we're thinking the image x is x minus c, and we haven't really changed y. Okay, so that's how the point has changed. And if you look, so what we're really saying is the image x is the normal x minus c, because you're moving it to the left, and the image y is the same. Now, if you're moving it right, you're moving the graph if you have negative c, it's moving the graph to the right, but you're moving the graph in the positive direction of the x-axis. So the image x will be x plus the c, and the y will be still the same, because it doesn't, we're only affecting left and right here. So we can look at this example that way if we want to. So this first example here, the example, we're just showing you how you've done it normally. So if you said the function was 1 over x, but we said now sketch the function of x minus 1. Every time you see x, you put x minus 1. So we've done that here. So we know this moves the graph, moves the graph to the right by 1 because of the negative. So now I'm going to show you how you can do this with, or to show you how it works with the image points and stuff. Okay, so if I said for the graph of 1 over x, translate it 1 unit in the positive direction of x. So if we think of the new image x, we want to go, it'll be the normal x plus 1, okay? And the y doesn't move because we're using left and right. Okay, with this one, find the new image of the curve with the equation where fx equals 1 over x under a translation of 3 units in the positive direction of the y-axis. So we know we want to move the graph right by 3. So if we were thinking of the image of x, it'll be x plus 3, and it says then, and then move 2 units in the negative direction of y. So the y has been y minus 2. Okay, so we could just set that equation up normally. So we know 1 over x, if we want to move the graph, we put to the right, we say minus 3. And if we want to move it down, we say minus 2. So we can do that like that. Otherwise, we can use the image points that we've created over here, where I said that was that one and that was that one. So here I've written it out. So the original point on the original function was xy. Then we change it to x plus 3 and y minus 2. So the image of x is x plus 3. And if you rearrange them, we want to get x by itself so we can put it back into our original formula. So we know this is actually what our x is now, and this is actually what our y is now, because we've transposed it. And then we put it back into the original formula. So where we saw y, we know here, this y, we know that it equals y plus 2, and we now know x is equal to the x minus 3. So you can see then, if we move that, sometimes we can write it like that, or we can move the 2 over here and get this one, and then we could have it like the same. It's the same as this is the same. So we probably really want to concentrate now on using this image formula stuff.